server. There we go. Okay. Let's find Twitch real quick. Okay. Just getting everything finalized, making sure that volumes are working and stuff, guys. Let's go through and double check everything. Alright, so that all seems fine. Okay, cool. So today is episode 3 of going through and doing some game development stuff. Last time we went through and we made, so the first video we went through and we made Pong. We showed how to set up SFML, how to create a simple game state management system. Then with the second video we went through, we made a very simplistic Space Invaders clone. This helped us to go through and do things like object management and stuff and making a whole object system. So we can go through and create things like characters and such. This time around we're going to go through a bit more of a complicated game. We'll see how well this goes. This is kind of an experiment in and of itself. But the goal of this is to go through and create a very, very simplistic RPG that I'm going to go ahead and call Roll Call. And basically the idea is going to be that roll call will take place in a small little like school type setting, and you'll have to do simple tasks like going to class and things like that. It's a very, very basic idea, but it allows us to do some very interesting mechanics. The big things I want to do is I want to be able to implement, obviously, multi-directional walking around. I want to implement a very basic talk to other characters system, displaying text. And then different types of ground and stuff, so that will affect your speed and how fast you walk. And finally, essentially a battle screen when you go into classes and stuff. We'll figure out how we want to do that as we kind of go along. I'll take suggestions as to what people want to see. The big things that we're going to be going over in this as well, however, are how to do things like tiled. Go through and double check I'm not dropping any frames. I don't believe I am. Where's OBS? There it is. Nope. Okay, so the big things we're going to go over as well is how to use a nice little program called Tiled. And for those who have not seen Tiled, here's a quick little peek at what it looks like. And we're gonna go through step by step and show how all this works. But before we do that, let's go ahead and I'll get our project set up. Again, this is all going to be pretty much the same thing as before, where we go through and we copy a lot of the code from the previous projects. That way we're not spending a whole lot of time doing things like recreating our state management systems and stuff. So let's go through. What we're going to call this is roll call. Go ahead and create the repository. And we're going to go ahead and publish that, and a simple PG for Twitch. And do that. There's that. And done. So I will go ahead and put this link in the description on the Twitch channel. So go ahead and take a look there if you guys want to see that. Here, roll call. Previous streams. So yeah, you guys can just go down and you'll be able to find it down there. GitHub. So that is now in the description below, so you guys can go through and follow along from there. And now what we're going to do is create our Visual Studio project. And call this roll call. And this needs to go into our GitHub. And it's going to be dash or underscore. make sure it shows up in there by doing that, and then do OK. And so we've got our whole project created in there. And let's go. Oh goodness, everybody wants to see my place apparently. So now that we have that, let's go through and open up the previous project we did, which was invaded. And we're just going to go through again and copy a lot of this in. There's no need to go through and do anything special for that. Go ahead and copy our DLLs. Put those into there. And then we'll come here and we will copy, we're probably going to want to copy entity manager, game over, lives, main game, main menu, score. We don't need ship, we want windscreen. Ooh, not sure what I did there. I accidentally copy pasted everything. Okay, let's try this again. Entity, game over, lives, main game, main menu, score, windscreen, don't need bullet, don't need enemy, want entity, game over, game state, lives, main game, main menu, score, windscreen. And that should be all good. We'll also go ahead and I'll copy our graphics and sounds. And that should be it. So now we'll come here and we'll make sure we click on show all files. Go through and select our headers and C++ files. Include in project. And again, add in our filters. So we have core, which is going to include entity manager. We need to make sure that we update our project here. So come to here, edit, and then do // third party build /include, and do the same thing for the library files. And come here. And then let's just go ahead and open Invaded's project real quick so that we can copy that over. So there's all of that. And we have core, we have entities, and we have states. Add states, and we have entity manager, can go into core, and then game state as well. And then game over, main game, and windscreen, main menu. Oops. Those can go there, and then those can go into entities. So there's all of that. And we're going to do the same thing for these source files. So we're going to have a core filter and an entities and states filter. And add new filter states. Go into there. Then we have game over, main game, main menu, and windscreen go into states. And we have lives and score, which go into entities. So there is our basic setup for now. So let's go into here real quick. We're going to compile it and see where all the errors are. There should be quite a few errors, mainly because of the fact that there are some things missing. So right here, we'll notice we're missing ship and enemy. That's because our main game is missing all of that. We can go ahead and remove a few of these things, though. The other big thing we can remove here is the ship. We're just going to comment that out for now. And we can go ahead and remove that, and it should be good. Enemy count, where is that? That's in main game. Count. There it is. So, there's all of that. If we come in here, we can say that the game runs just like normal. Clicking play, though, won't really do anything. It's just going to show up with an empty screen. So let's go through now and modify this a little bit. And we will go through and change it up to look a little bit prettier. And yeah, I've got a little bit of background noise. That's the fan in my apartment. It's a little loud. I apologize for that. Not a whole lot I can do about that, unfortunately, unless I want to freeze to death, which I kind of prefer not to. And we can go ahead and close that. So, let's go into here to main menu, and let's change this from invaded to roll call. And let's go ahead and set the color of this to something else. So, play, quit, title, what do we set that? Did we not set that there? Oh, I guess we kept it white. So we'll notice that that's a little big for this, so let's go ahead and size that down to 250 for the font size. And that's still a little big, so we're going to go through and shrink it even further. Hopefully that'll be a bit better. Yep, there we go. And this time around what we're going to do is we're going to change it from red to, let's go with blue. Make it a nice blue color. So now we have our simple game all ready to go. We have our main menu. We can already go into the game and go through and do stuff here, so that's pretty much all situated like we want. The big things that we're going to want to do is we're going to want to make sure that it is not paused by default in the main game. That's because when the game starts, it should automatically just start up the game. And the big way that we fix that is that we want to make sure that we are checking that the keyboard, that the previous key was not returned. The previous key pressed was not the return key. So, what we want to do for that is we will leave that there. And then we want to set that to true, because as soon as we enter, it's actually going to be automatically set up. We're already going to have pressed enter, so that's why we're going to have that. So now when we go in, because the enter key is pressed when we select this menu object and we go in, now it'll automatically not bring up the pause menu. And you guys could go back and add that into the other games as well if you so desired. I kept it before because it helped kind of keep the pacing of the game better. So, now that we have that, let's go ahead now and add in some other stuff. So let's change this from ping, because we forgot to do that last time, to roll call. And that will also change the title up here. So we've got all of that ready to go. Now we can start on the fun part, which is implementing the actual game. So before we go ahead and start all this, let's go backtrack onto how most RPGs work. This is kind of an important concept of what exactly we need before we can go through and make this. So obviously a lot of this stuff is already set up. We have things like character collisions, key presses, sounds, graphics, etc. All of the core stuff is already there. Getting a character to move around and stuff is actually not going to be all that difficult. The real challenges that we're going to face are how do you create dynamic worlds without coding it all? And this is kind of a neat concept. A lot of games use something called a tile system. The best way to think about it is that in an RPG, in a role-playing game, generally you're only going to have a few different types of graphics. For example, you're going to have for example, grass tiles, and if you want snowy grass tiles, then you just, draw a little bit of snow on top of them, or you swap out the colors. You might have sand, which might just be another alternate color to your original grass tiles. A lot of these things are pretty basic, but they do have different details. But generally speaking, a lot of your tiles are going to look very similar. There's some variation, but you can reuse it in creative ways and get away with not needing everything to look different. And the way that we do that is we use what's called a tile editor. So the best way to think about it, what I'm actually going to do real quick is we're going to go find a tile map. So for those of you who want to make your own games, I highly recommend opengameart.org. A lot of this art on here is free to use depending on what you're using it for and such. But there's a lot of neat little graphics we can get here. The big thing that we're going to want in this case is we're going to want 2D art. And we are specifically going to want this to be a Creative Commons license, which is basically it's open to everyone. And we're just going to go through and search everything for right now. We can of course apply other filters. We're going to go through though and try and find just some simple top-down graphics. Usually those aren't too hard to find on here. And I'll make sure to give whoever credit, whoever's we use. So let's see here. This is kind of the fun part. You can go through and see, here is exactly what we needed. Tiles. So you'll notice that there's not a whole lot of special stuff going on for each of these, but there is some slight variations. So what we can do, and you'll notice this is public domain, so we can go ahead and use it, and I will be able to include this in the project. So now, let's go through and we can close invaded and bring this over here, bring this right there. Over to graphics, extract that, and extract that. So, we have our tiles here. Now, the big thing with these right now is that they're kind of broken up. This isn't a huge issue, but it will make loading our graphics a lot faster if we go through, and we combine them all into one thing. So let's go through and do this. We're going to load this up. We're going to see what the sizes are. The size of these tiles is 64 by 64. We have 1, 2, 3, 4, 5 of them. So we're going to want to get an image that can hold all of them. So let's bring up the calculator. 64 times 5 is 320. So let's go ahead and do 64. We'll do 2 on the top, 2 on the bottom, and then 1 on the next row. So we're going to need a 64 times 2 for the width, which is 128, and 64 times 3 for the height, which is 192. So we're going to need a size of 128 by 192 to fit all of these. And now what we will do is we'll come here, and we're going to click on Image, Configure Grid. And the grid's width and heights are going to be 64 by 64 in this case. This is basically going to create a grid that we can view, and we can use this to properly place our tiles. And what we can also do is we can come here and do Snap to Grid. So now, when we come in here, we're going to select on this, make sure you click Move the Active Layer. You can now go in and it'll automatically snap it to that. So we can do the same thing here. We can paste that in. And that doesn't seem to have been too different. So we messed up. Okay, so we actually have to edit these. And again, bring that there. We'll just go ahead and open all of these up. 2, 3. Close that. So there is our nice and shiny tiles for right now. So now what we can do is we can come through and export this. We're going to go to GitHub, We're going to roll call, graphics, basic tiles. And now that we have some basic tiles to use, what we're going to do is we're going to come back over to our close that. So let's come over here now to tiled. Okay, so for tiled, we're going to go through and create a new tiled map by clicking on that. You're going to want orthogonal, which basically means top down, and the format is going to be XML. We don't want any kind of compression or anything. Tile render order is basically the direction it's going, so you're going to go from the top right-hand corner down to the bottom right-hand corner. So we're going right and down because our game starts with 0, 0 up here and has a width of going out to here and a height going down to here. The map size. So the tile size is going to be 64 by 64 because that's how big each of these small images was. If we come in here to properties, we can see that they're all 64 by 64 in size. So we need to specify that, and then this is actually going to be how big our level is. So 100 tiles is going to be 100 times 64, which is 6,400 by 6,400 pixels. We don't really need something that big right now. We're going to go for more of a Zelda style top-down where when you go to the right or go through a door, it goes out. So what we actually want is we're going to want something similar to our game's window size, which if you come back here, you'll remember it's 800 by 600. So bringing up a good old calculator again, if we do 800 divided by 64, you'll notice we get 12.5. Same thing with 600. If we divide by 64, we get another weird number. So what we're really going to want to do is we're going to want to go through and do 800 divided by 64, which gives us 12.5. 12, however, times 64 gives us 768. So what we're able to do now is we're able to go through and get the aspect ratios based on that. What I'm going to do is I believe 1280 divided by 64 comes out even, and then we can come here and do 768 for that. Because 768 divided by 64 is 12. 1280 divided by 64 is 20, which means we can have a 20 by 12 map size to fit on the screen. I'm going to do 20, 12, and that'll give us our perfect resolution to match this. So this will go through and make it so that it takes up exactly the screen size, which is kind of what we want. Well, take that back, not kind of, is what we want. So we're going to go through and create that. So now we have this nice shiny map, but we can't really see anything on it. You'll notice that when I'm on the map, it's blue. When I'm off, it's red. So now what we need to do is we need to tell it where our tile set is. So we're going to come here, and we're going to do Browse. And we're going to want to come to Documents, GitHub, Roll call, graphics, basic tiles. And we're going to open that up. Tile width is 64 by 64. We don't need to use a transparent color or anything. This is so that you can add specific colors that are marked as invisible. This is very useful on older systems where you might want to have certain colors not visible. So we'll go through and do that. And now we can go through and we can select a tile, and what we're able to do is do our tile system. So one other thing I want to do, I haven't actually looked too much into this. We want to show some kind of background color. Here we are. So let's go through, and we're just going to make this background color for now red. That way we can kind of see everything. And that didn't work all that well. Huh. Kind of surprised that they don't have a map. Anyways, so what we're going to do now is we're going to go through and create our basic little layout. And what we want to do is I'm not really sure. So that'll be easier now to go through and figure out where everything is. So we'll just go through and do that. So there's all that. And just there. Okay, cool. So now we have this nice little tiled system going on here. And you can see that it works pretty well. So now what we can do is we can do things like come up here and make it all look a little different. We can add some variations. I'm not going to go through and do that right now. The one thing I do want to do, however, is I want to add in some walls. This is basically going to be our boundaries for the game. And let's see what they marked each of these as. I'm actually not sure. Wall top. Stones shaded. So this is supposed to be, I guess, not there. I guess it's supposed to go like right there type thing, maybe. Not really sure how they lay this out. Doesn't look like they showed too much. Oh yeah, okay, it goes on top like that. So what we can do is we can take that and then take this like that. This like that. So there's our nice little courtyard look to it. And of course we can do other things like go through and add it down here as well. Not much of a need for that, but we'll do it anyways, just to add in boundaries. And there's a basic little, if you will, courtyard area. And we can, of course, add those there. Cool. So we have this little area. What we're going to do is we're going to make it so that the only spots that you can walk on are these tiles here, and these here are not able to be walked on. And we can do nice little things as well, like copy this over. Later on we'll be able to do things like that, like make an entryway and stuff. But for now, let's go through and just save this. So the normal format from this, for what you can see, is TMX. TMX is a special kind of format that I am not really wanting to figure out how to parse through in this. As a result, we are not going to be using that. What we're actually going to do, and this is kind of a neat thing, is we're going to go through and export it as JSON. So JSON, for those of you who have heard of it, is a really popular web format. I'm not really going to go into describing it too much, but for those who might want to port this to something like a HTML5 game, this will actually make it a little bit easier to do so. So we're going to go through, and we're just going to name this test. This is just going to be our test area. And now what we're going to do is we're going to come back here, and we have our test.json file there. So to kind of show what this is exactly, I'm going to open it up in Sublime Text, and we're going to show you real quick what exactly this looks like. So if we go through, we can go through and see that we have, a height property of 12, and we have the name of it, which in this case is tile layer 1 for this particular layer. So the way that's sorted out, first off, let's go into this. So we're going to go through and collapse some of this to kind of go through and make it a little easier to read. Okay, so the first thing we have here is a height property. This is basically just the height of the map, which is 12 tiles in this case. We have our layers, which we'll go into in a sec. Next, object ID, which is the ID of the first upcoming object. It's hard to explain that one. I'm not entirely sure. It's basically an ID for the next object, based on what it says. Orientation, which in this case is orthogonal. That basically is that whole top-down perspective. Properties, which is for special things. We're not worrying about that. Render order, which in this case is going to be top right, right down. So we'll start from the top left, go right down, etc., etc. Tile height, which is how big the tile heights are, how tall the tiles are, the tile width, the version, and the width of the overall map, which is 20 tiles in this case. So let's go and explore deeper. So starting off, we have the tile set itself. We have our first grid, which is the starting point of it. We have whatever image we're using for our tiles. We have the width and the height of that image from right here. Offset margin, so if we wanted to have certain spacing between every tile, or a certain offset to the first tile, we could. The name of it, some special properties that we're not using. Spacing, so like let's say that every tile had 10 pixels of space between them, we could see that. The tile width and tile height, so in this case 64 by 64. So this basically defines what our tiles look like, which if we go back to GIMP, this is what our tiles look like. 64 by 64 in space, no space in between, and the image size is 128 by 192, as we can see here. There's no offset margin because it starts right as the image starts at 0, 0. And yeah, so there's all of that. So then we get up here to layers. Now this is the important part. Before we go over data and how that data format is, I want to go over the other stuff first. So we have the height, which is 12 tiles. We have the name of it, which is tile layer 1. Opacity, which is how visible it is. In this case, we have 1, so we're not transparent at all. We're fully visible. The type, which is a tile layer in this case, whether it's visible, which it is. The width of it, which is 20 tiles, and an X and Y offset, which is 0, 0, because we're not offsetting it by anything. So the data, okay? You might notice that this is just a string of numbers between, so it's either 0, 1, 2, 3, 4, 5. In this case, we don't have any zeros. This is because the way that this works is that this is these numbers indicate which tile we're using. So if we come into here, we can see that the first tile, which is our top left-hand corner, is 4. So it's right there. If we go through back to our image, we have 0, 1, 2, 1, 2, 3, 4. This is tile 4. Now you might be wondering, normally in code you use 0 as your starting point. The reason that this is not 0 is because 0 would be if there's no tile. That's a very, very specific thing to mention. So let's come here and we'll erase that, we'll resave it. You'll notice now that this has been updated to 0. That's because that tile has nothing there. If we undo it, we go back, you'll notice it's now 4. So basically this indicates tile 4. So down here, our next row is going to be what is that? Tile 5. If we come into here, we should see that, and we do, right there. And you can go through and you can read all of this and see it's all pretty straightforward. So what we need to do now is we need to go through and parse this in our code. So we can go through and read all of this. And what this is going to let us do is it's going to let us do a couple of things really easily. One, we're going to be able to handle collisions very, very easily because of this. I'm not going to go into that fully quite yet, but you're going to see how in just a little bit of why this is such a much better way of doing collisions. We're going to be utilizing a concept called collision maps to do so. And second of all, this will also let us render everything much, much more efficiently. Rather than having to draw out and export this gigantic image, we can go through and we can render this to the screen directly and not have to worry about little things like, is our image too big? Are we using up too much memory? It's all much, much easier as a result. So we're going to go through and do this now. So let's go through and begin. So first thing I want to do is I want to bring up this program right here. This is what's called a program called Jasmine. It basically is going to let us go through and read through a JSON file. It's basically just a minimalistic JSON parser in C. It'll work though in C++ as well because they have all their proper if defines. So how does this program work? Well, first of all, we come through and we import it, which should be right there. And what we do is we initialize our, JSON parser right there. We go through and we tell it what to parse, which in this case, believe, actually, wonder if I want to just make this even simpler. Oh, I suppose we can go through and just make this even easier. So what we're going to do now is we're actually just going to be very, very lazy with this whole situation. We are just going to go through and we are going to take this and create our custom tiles. So, maps. And we will save this as maps.s.map. So we're just going to go through and copy and paste this in directly, and we can go ahead and keep the commas. We're going to go through, though, and make a very simple file parser to go through and open these up. So let's go through now and make a new class, which we are going to call map. There's that. So map, and once. Graphics.p. And this is basically going to inherit again from Sprite as well. And actually, what we can even do, we can copy most of this. So this time it's going to be map. And we're going to have a very similar setup as we did before with our, it's going to be a very, very similar setup to our sprites, except it is going to be a little bit different in how we handle everything. So let's go through and see what exactly we need. We need our update method to be able to render it. No, we don't need that. We need the update method for collision checking, though technically not really in this case. But we can use that for some neat effects later on, so I'll go ahead and I'll keep that. We have a check collision method, which is going to be used with entities in order to check for collisions on tiles, and we'll define all those methods later. And then what we're going to want here is this is actually going to return what tile number we're colliding with, and we'll do different things based on that. And we don't need a group ID. We don't need an active. Destroy we'll go ahead and we'll keep. And that should be good for now. Come down to core, new item, map. And we're going to need to copy a few different things. We're going to need each of these. And actually, we're going to save ourselves a bit more time by copying this. And then we have that. Don't need any of this. We don't even need our destroy method either, actually. Close that. All that. And we put this into maps. And then this texture, create, and we're going to give it a width of whatever our width and height are in here. So I'm going to have this be a very specific file format. We're going to have the tile width, tile height, map width, map height. And then, so there's all that, and then we will have, what do we want for this? Let's go ahead and make this first property the image name, which in this case is basic png. So notice everything here is going to be comma separated, making everything nice and easy to parse. So the first thing we're going to want to do is we are going to want to go through and open up a file. So what this means we need is the C# or C++ file IO stuff. So if stream. Why is that not showing up there? That should have been. We need IO stream first. And then what we're going to do is we are going to come here and do std if stream, and this is going to be our map file, which in this case will be the file name. And we want to go through and read everything. So okay. Where's the EOF? Sorry, I'm trying to make sure I'm doing this right. There we go. So go through and read each character. And so what it's going to do is it's going to go through and read the, it's going to have a state management system. So to start with, we'll go through, we'll say for state 1, 0, what we're going to have is std string tile set, and tile set is going to get each character that we read while it's there. Until we get a comma. And so that'll go through and get that. Then, for case 1, we are going to have a temp string, and this temp string is going to be what gets that. And the temp string should be reset each time. And we're going to have a width, height, tile width, tile height, and then we finally finally need our tile data. Now, most of this can actually come into here. And finally, we have our int times data. And can we do a double point again? Cool. This is going to be kind of cool. Okay. Case 1, case 2, case 3. Okay, so case 0, we don't need to do anything for. Case 1, we need to go through and we need to set the tile width to be equal to actually what we can do. There should be a limited way to read this. Here's what we'll do instead to make this even easier. We will do everything on separate lines, which will further make things easier for us. So, there's that. I apologize. I probably should have planned out this parser a little bit better previously. Got string included, right? Yep. Cool. Is there no get line? And then this will be, okay, this tile set. So that'll go through and that will get our tiles there. There we go. tile height, and then the width and height of the image, which these need to be multiplied by the tile height, the tile width. So, tile set, tile width, tile height, width, height, and then finally we have our data here. And finally, we need to read in our data. So in this case, is equal to new int width. And actually, I'll just go ahead and leave that like that. Okay, so there's that. And let's take this, and we're just going to make this a single pointer, because I'm too lazy to go through multi-dimensional. Alright, width, and then what we want to do is we want to do that file, goes into that, and then goes into and then this width. And that should go through now and be able to read in our file. And now, let's go through and hide that. Actually, come up here. let's come here. We'll just create a simple test map right here. There's that. There we go. So now if we come over to here, and go ahead and see that we've loaded in our map successfully. So we're all set there. It's able to read in all the various properties fine. So now let's go through and start the process of using that map. So as of right now, what we want to do is come down here and first remove this, and remove that. Alright, update. Okay, so now what we want to do, draw. There should be a way to draw and spreads. Thought. Guess we have to do it on the texture. Okay, so now what we're going to want to do is we're going to want to have two parts to this. We're going to want to have the normal texture, which is used, and then a texture for the tile set. So, here. Use that. And this file, which will be in graphics / plus this file set. Now, we want to come here. We want to make sure as well that we close the map file. And then we come here, switch, actually, planned this out enough, it seems. Let's see here. I thought they had something for rendering with tiles. Create image. Okay. Cool. So, now what we can do is... Okay, now that I've got that figured out, sorry about that delay, so let's go through and set that up. And then we load that like normal. And then what we're going to do is we are going to go through and basically figure out how many tiles we need for everything. So in this case, we have 5. We're just going to hard code that for now. And then we're going to do so copy that. Dest x should be 0, 0. And then we have, in this case, 0, 0. Visual Studio has decided to freeze on me. Oh joy, good old Visual Studio being slow. There we go. We only have 2 tiles per width, so we're going to just keep that like that. I believe indirect takes in. Yep. So. Okay, so we have tile 1, tile 2, tile 3, tile 4, 1, 2, 3, 4, and the last one we need is 5, which is 0, and that's 2 times the tile height. And then switch this data x plus y times this width 0, great, case 1, texture, update, and we're going to use tile 1, x times 64, y times 64. And we're going to do the same thing with the other tiles as well. 1, 2, 3, 4, 5. And then come here. And that will go through and draw that. And let's go into main game now. Main games. Here, load, so, not quite right still, however. And the problem there is that it tried to access an empty image. So, let's double check what is going on here. So, go through, play, and we'll make sure that it is going through. And we'll notice here that it did not open the graphics properly. So, that is where our problem lies. Basic tiles, okay. Base tiles, very different names there. So come here, click play. We're not getting any of our same errors. And again though, we got the same problem. So let's double check this one more time. And there's our issue. So let's see here. So, that is where our issue is stemming from. That should have worked. $64. We must need to create each one of these as well. And there is our simple little map being rendered. This is exactly the same as our previous one here, so you can see. And it's pretty easy to go through and modify this. Obviously, we'll have to go through and just recopy the data, which is not really that big of an issue, but we can go through and do that real quick. So let's go through and make like a little entranceway there. And now what we have to do is come here, copy this, paste there, and if we load it back up into here and we click on play, we've got our nice little entryway there. So there's the basic start of our game. So now what we need to do is we need to go through and update it to be able to have collisions and such with it. So let's go through into main game. We have all of that. The next part that we want to go through and do is we want to be able to get where the entity is colliding with. And this is actually a pretty simple thing to do. We need an X position and a Y position. And what we're basically going to do is we are going to return what tile is at that position. You'll see in a sec how this exactly works out in the end to give us something usable. So the entity, we're going to take its get position dot x, and what we're going to do is we're going to first off convert that to an integer. This will go ahead and set it to not have any kind of decimal point, since that's normally a float. The next thing that we're going to want to do is we're going to then want to divide that by the tile width. And what that's going to do is it's going to basically shrink it down to a coordinate system that we can use with our data array there. We're then going to come here and do the same thing with the Y position, and that'll let us go through and get what tile our character is on. Now, this is of course going to be useful for what tile they're standing on, but not what tile they are hitting. So what we need to do now is we need to make sure as well that we can get the edges of the character as well. So we need an up, down, left, and right collision system as well. So what we're going to do instead is we're going to go through and we're going to add in variables here. We're going to add in a direction to this. So let's come up here. We'll do a type volume 0 is equal to 2, down is equal to 3, direction here. Okay, and then we'll come here. 0, case 1. I'm going to do that, and next. Actually, let's go here. And remember that our characters as well are going to all be the same size as, they're going to be a little bit smaller. Well, I don't need to worry about that. So, entity width. Left, right, up, down. height over 2. So that'll go through and get us the center position of the sprite when there's nothing, and then when we specify a direction, we'll get the left there, the right there, and then we're going to come here, and we're going to do the top, which is that, and then the bottom right here, which is that. And that'll let us go through and get the tops and bottoms of the sprite as well. So now we can do different directions detecting there. My girlfriend's on the bed here, so she's just making a little bit of noise. It's fine. So now we have that. Let's come over to here. Let's add in a main character now. Extends. Now what else do we have in entity? Let's go through, double check this. So we have to override the update method and the collision method. And we're also going to want to go through now and, well, I guess we don't need to do that quite. Well, do we need to do that at all, actually? Not really. Big thing we're going to want to do is we're going to want to store. Every character needs to be able to handle collisions. So there's all of that. Guess we don't. Thank you. Glad somebody else here uses SFML. I've really, especially after doing a lot of this, it's really proven itself to be really, really nice for doing things like this. I can't imagine trying to do this all in OpenGL as well. That would have been annoying to Joe. Okay, so we have our entity there, main guy, got all of that. So, public, private, we need to override the update and collision methods. And that takes in a render window. And that takes in and then this is going to include this is going to override his update method. So right now we're starting on actually coding the game. So far what you've missed, worst coffer, is that you've missed us going through and just showing a little bit of tiled and how to use that, as well as our file format, which is a modification off of the JSON data, so just taking what we need rather than everything. So you can see that all right here, which just is the tile sheet, the width and height of tiles, the width and height of the map in tiles, and then the actual tile data for it. So now we're going to go through and do is we're actually coding a simple main character to be able to walk around and do stuff. So we have our main guy collision and entity times entity. And that'll handle our entity collisions there. So now that we have that, the last thing we're going to need is entity overloader there. The working build is, actually, let me go ahead and update this onto GitHub. Let me just go through and fix this. There's that, there's that, there's that, there's that. Oh, and public. What do you mean no clear definition? Oh. That, and there's that. That should have been working. Pragma ones. What did I do? We're stuck in that kind of loop. Okay. No worries then. We will not include that there to make this a little bit better. And go ahead and get rid of that. Alright, cool. So let me go ahead and put this onto GitHub. So yeah, if you check down in the bottom there, AS96, you'll be able to see that GitHub repo in the description below. Okay. Alright. So, that is now going online. Once that is done, there you go. So yeah, you can go down into the description below. There's a previous streams section, and under there is the roll call GitHub directory. And yeah, I was originally gonna use TMX. There's a couple of libraries out there, but they're all really, really convoluted. The one that I was shown, let me see if I still have the link up right now. Don't believe that I do, unfortunately. But what I'll do is I'll go through and I'll link to the TMX loader in the stuff below when I get the chance. That way you can go through and see what that's about. It's a pretty convoluted parser. I'm not a huge fan of things like that, but you know, up to you. So let's go through now and update our movement. So what we're going to do is we are going to do this velocity x is equal to SF keyboard is key pressed, SF keyboard key right, SF keyboard is key pressed, SF keyboard key left. We're going to do the same thing for the Y, and then we're going to have down minus up. And this will go through and give us our basic movement. And we'll come over here to the game, and we're going to add in here main guy, and make sure we include him in here. And he is just going to take in let's see how this came out. I think we need to render the order of things a little bit differently. Oh, we forgot to give him a graphic. Would be pretty important to do. And what we'll do is we'll make him a ship for now. I forgot to undo this. And there's our little guy up there. We can go through. Can't seem to move him around right now, because we forgot to do entity update. So there's that. And we can now move our little character around. He's perfectly able to move around and everything. The big thing that we're going to want to do now is we're going to want to, okay, not a problem, yeah, just check it out tomorrow. The GitHub repo will be online. The YouTube video of this will also be online. That'll probably go up sometime tomorrow as well. So, we have our basic little character. He can move around and everything. Nothing preventing him from doing that. So now what we're going to want to do is we're going to want to go through and update his collisions as well as his starting position. Now his starting position is actually going to be based on the level. So in this case he'll start in the center, but sometimes we might want him to start in a doorway, sometimes we might want him to start somewhere else. So let's go through and give him X and Y position. X float Y, set position to X, Y. And now we can give him a starting position, and then what we're going to want to do is we're going to want to come here. We're going to set him, in this case, well, yeah, I guess we can do that. What we're going to want to do is we're going to want to come here, and in the case of this, basically, depending on the starting position is going to change each time. So what we're going to want to do is we're going to want to give a starting position variable. We don't need the enemy count anymore, but we do need an int. Starting x and starting y. Yep. Yep, I do upload these to YouTube. You could see the previous one below. So yeah, I really am trying to document these. I think this is a neat thing to be able to go through and do and show everyone, you know, basics of game design and how you guys can go through and make your own games. I think that the goal at the end of this is going to be to have a very, very simplistic library. So you'll be able to go through and use this in any of your games. They'll be put under the MIT license, so you don't have to worry about things like who owns it and all of that. You'll be able to use it for, you know, commercial games and stuff. It's not going to be super, super advanced, but it'll be good enough that you can do some pretty neat things is my goal. This, of course, is one of them where I'd like to be able to get basic games made, like basic RPGs and stuff. So let's go through real quick, and we're going to want to set the default position to 768 over 2 and 1280 over 2, and I nearly forgot this should be floats, not ints. So now we'll start right in the center of the screen. And I apologize that the window keeps appearing off screen. It's because I am currently using a dual monitor setup, and the main monitor is set up to be this one so that messages and stuff that appear won't interfere with the video. So now that we have that all set, let's go through and do some simple little collisions. So what we're going to want to do is we are going to want to set it up so that our main guy can collide with different things and have them change around his physics. So let's go here. There's a map. We need to go here and include map.h. And we need to give him a map with a starting point. So there's that. And now what we can do collision, and what we're going to want to do is we're going to want to basically have it so that anytime that the player collides with a tile that is greater than 0, 1, 2, so greater than 2, then they should not be able to move. So check the left side first. And what this is going to do is we're going to have a while loop there, and while they're colliding with something to the left, we're just going to move them to the right one. And we're going to move it by 0.5 instead, in order to just kind of minimize how much, in order to make it more precise. And if you lower that number, it'll be slower, but it'll be more precise effectively. We're going to do the same thing for top and bottom. So we have up and down. So up, we'll move him down, and down, we'll move him up. Oop. One other thing I forgot as well. So we have to do that first of all, but also we want to make sure that it's only while it's greater than 2. So let's see how this looks. Go here and run this, and see if that is shot. Now you'll notice in this case that he moves all the way over, and the reason for that is that he is, I think I did those in the wrong way. We'll go over why that is in just a second. So, double check this is okay. So there's that. This is going to break. Oh, that didn't break. So, it's all set. And that broke. So, reason for that is that we need an if statement, not a while statement. And what we need to do is we need to set it to be negative of whatever velocity he is at. So in this case, go through and do that, and then do the same thing but for y. Do that, and do that. The final thing is absolute value of it. That way, we don't have any worries about positives or negatives affecting this. There. And that'll make sure that he stays the proper distances away. Ta-da! And of course, we can add in different types of other cool properties as well. So right now you'll notice that this is just the basic collisions. So, that the floor doesn't really do anything special. What we can also do is, let's go through real quick, and let's add a speed variable to it. So, float speed. And what this is going to do is this is going to move him at a different rate depending on the circumstances. So we'll go through and do that, and then put parentheses around this because order of operations in math. And there's that. And what we're going to do is we're going to do switch collision with this none. So, if it is a normal tile, then he's just going to move at that normal speed. And what we're going to do is this other tile. So remember over here in this, we have an unused tile right here. So we're going to go through and put 2 of those right here. Save that. We're going to come here. We're going to grab our data from there. We're going to copy and paste that over. And now what's going to happen is every time we collide on those tiles, he'll move at half the speed that he normally does. And this is kind of cool because we can do different effects such as lava, we could do water, so you'd have to go swimming, you can change the animation around. Let's go ahead and show that real quick. We'll simulate water with this real quick. So, normally this set color to SF color white, and we'll make him go blue if he is on the water quote-unquote tiles. So let's come here, and now if we come up here, he turns blue when he's in the water, and he turns white when he is not. So we can do little things like that. There's of course a whole variety of other effects you can do with this. So this allows us now to go through and focus more on the fun side of designing our levels, designing our worlds and stuff. We don't have to worry as much about it. Silly stuff like that. So now the big thing that we're going to want to do is we're going to want to go through and make it so that we can do things such as transitioning between areas. So I kind of actually like this idea of using this as our transition, our way to know that this is like a doorway and entryway. So what we're going to do is we're going to say that whenever he collides with this tile, he's going to go to a different map. And what we need to do is we need to specify these entrances in our custom format for everything. Now, there's a couple of ways that we can do this. the easiest way that we could go through and do this is we could go through and specify that different tiles lead to different doorways. That's one easy way to do it that might be the best. Another way we could do this is we could have a whole bunch of special mapping. We go into our custom format and we say, I don't know, entrance 1, and then space, and then we do, I don't know, or do a new line, and that goes to cast2.map or something like that. That would be another very easy way to do so. I think what I'm going to do, though, is we're going to keep this very, very simple, similar to the old school Zelda style games. And what we're going to do is we're going to have an up and 4 possible entrances that could be used. We're going to have an up, a down, a left, and a right. And so what this will let us do is go in and specify that, okay, if the character is gone up too far, then they are going into the next up area. And then what we're going to do is we're going to have each map name here, here, and here. So if you only use, well, I guess we don't even need to do that. We could specify it so that we can connect it into a giant grid world. So let's go through now and do this. And again, all seems to be working pretty well. Let's double check memory usage real quick as well. Yep, we could do a Zelda-style dungeon transition. That wouldn't be too difficult to do. It would require a little bit of work, though, for any kind of nice animations. So let's see here now what we've got going on memory-wise, just to make sure that we're not doing anything too crazy. I know that there's the font bug, but other than that, it seems to be okay. The big thing we need to make sure that we do as well is that we destroy all of our images when we're done. Now these ones are all okay because they're not pointer references. They're going to be deleted as soon as this ends. The big thing we need to delete is the tile texture. So let's come down here and we'll do delete that. We also want to delete the data. And we're done. And I think that that's going to be it. Texture data, yep. Cool. And because, again, this is not a reference, a pointer reference, we're not using new, we don't need to do anything special. That should help lower down the memory usage a little bit better as well. So there's roll call using 23.6. And again, most of that memory spike you're seeing is going to be from the font bug that was mentioned in one of the previous videos. So, okay. Anything else that we need right now for that? Okay. So let's come here to map, and what we're going to do is we're also going to have some other names. So we're going to have string top file, top, bottom, left, right, and these are going to specify the new areas that we can go to. So top area is what we'll call that, bottom area, left area, right area, and those are going to be read in a similar manner to other stuff. So we'll come down here, we'll go to our load method, which is right here, and this is going to load in from underneath the data. And actually, you know what, we'll just make this easier. We'll put it underneath the tile data here. For top area, bottom area, left area, and and for now, we'll just make it all go into test map again, just to keep things simple. 2, 3, 4. And let's just double check real quick that that is all loading properly. So we have test map, test map, test map, test map, and basic tiles. So that is all working as expected. So now we can go through and we can specify those. The last thing that we need to do is we need to make it so that when test guy hits a specific tile, he'll start transitioning depending on where he is. We could either have it so that when he hits these tiles, he goes that way, or we could actually just make it so when he goes off the map in that direction, he transitions there. So we're actually going to go through and do that. So let's do this. First things first, we need to be able to specify what map is going to be loaded next. So for main game, we're going to create an external variable. It's going to be called next area. And this is going to be a string. And this is basically going to specify which portion of the world should be loaded next. So in this case, we'll have test map be the initial place, and then that is loaded in here. So now we can go ahead and we can change that elsewhere. So if we come here, we'll take this extern, we will apply it to our main guy right here. What we can do now is we had our entity manager. Okay, so we're going to go through and modify things just a tiny bit. First of all, our update method is now going to give back a status. Basically what this is going to do is it's going to allow us to skip over things that we don't necessarily want it to keep doing. So in the manager update, for example, the update method is going to need to be able to be broken out of at times because we're going to want to be able to transition to different game states. And when we transition, we don't want to keep updating the score and live stuff. So the first thing that we're going to do is we are going to give a, that is updated and then rendered. Yes, so what we're going to want to do now is we're going to want to give the update method of this an integer here. So change that there, and then come up here to entity manager and change that here. And this is not going to stay an int, however, this is going to be a, well, yes, so basically there's going to be two statuses. There's going to be, let me actually make that a boolean, and we're normally going to return true, and the only exception to that is going to be when we get something false here. Here. And come here to our update. And then we come here. And we come here. And we return true here. Now, what we want to do is when we break out altogether. So, what this means is we can come into here, we can say, and we're just going to do it for the top part for now, this position y is less than equal to 0. Then what we want to do is we want to transition to the map's top area. So what we're going to do is we are going to come here. We're going to set the next area to be equal to map top area. And then for state, which we're going to need to include, set state to new main game. Again, I'm here to include game. come here, skip over that, and what you're going to see is, hopefully, yep. So what that does is it basically just set us back to this next state. So we'll be able to do lots of cool things with this now. So what we're going to do is we're going to go through and we're going to create a new room. It's going to be the exact same size, and we're just going to come here and copy this all into there. And this time around, what we're going to do is we're going to take all of this, we're going to put it down here as well, and then we're going to go through and add some blockades right there, 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 and there. And this is going to be test 2 now. So, again, we're going to export to JSON. And then we're going to come into here. We're going to open up our test 2. We're going to copy this over, and we're going to make another test map, test2.map. We're going to copy this over, and the top, bottom, left, right. So top is to test2.map, and bottom is going to go to test. And then what we want to do is we want to take all of this data from here and copy this to there. So that'll be able to go through and do that. Let's give this a quick test run. Should in theory work. Of course it could still go wrong. And of course it works. Now the big thing you'll notice is that we ended up in the center. Now the reason for that is that we didn't update the position for